Good afternoon, everyone. Can you listen to me? Respond in the chat box. Okay. So today I will show you some test from the inorganic part, that is test for some anions. Okay. So today is test for anions. Now the anions is the presence of anion in a salt can be proved by two ways. You know about it already, these practicals are done. One is the dry manner, dry test, and wet test. So when the dry sample will be taken and the reagents is added, basically these are dry test, and wet test, that is we have to convert the dry sample, the sample to its solution phase. For this it should be soluble in any of the solvent. Now the basically used solvent is water here. Okay. So first we tie with the water. So what these solutions called? This is called OS, or original solution, that is prepared by the sample plus solvent in which the sample is soluble. Now what are the solvents used here? Basically the solvents are water and dilute HCl. But in your syllabus, as for not much more complexity, the water soluble sample is given. All the samples are water soluble. Now which one is water soluble sample? There are all the sodium and potassium salts are water soluble, or nitrate salts are water soluble. Okay. Now the dilute HCl is for the carbonates, because they are not soluble in the water. For this the dilute HCl is used. Now for the test of anion, we will selectively, I will show you some test, that is first of all for sulphite, SO3 2 minus. Now another one test is there, that is sulphate. So sulphate is very easy. Later on we will show you the test for sulphate. So first of all sulphide. So first we have to do, the dry sample will be taken and water is added to solvate it, then the appropriate reagent will be added. So just look at this. A very little amount of sample is taken in the test tube, then appropriate solvent will be added, that is I have told you earlier, that is water, distilled water is added to make the solution. This is the OS. Okay. Now shake it well to solvate the sample or the salt. Some of the compounds are easily soluble, that after adding the water it become totally soluble, and some are required to be shaked. Okay. Now it is totally soluble. Okay. Now we will add here barium chloride solution. So what is the reagent? That is sulphide is taken, then barium chloride solution, that is will be added here. Now a precipitate of barium sulphide, it is white in color. Okay. So just look at this. When barium chloride will be added here, just look at this. Just look at this, a very hardy PPT of white color is formed. Okay. Now Is this for sulphite or sulphate? To prove it, we have to proceed further, that we have to add here mineral acid that is HCl or H2SO4 etc. If it is soluble, the PPT is soluble, then it is for sulphite, and if it is not soluble, then it is for sulphate, because the basic reagent is same, barium chloride, both gives white PPT, one is for barium sulphide and another is for barium sulphate. So, if we add HCl here, then it again form barium chloride plus H2SO3. Barium chloride is soluble, it is transparent, so no coloration will be there. Okay, so next step is that addition of mineral acid to that. Now just look at this. I am adding mineral acid here. Okay. Now we have to minimize the volume to prove it. So we have to minimize it, just decreasing the volume. Now we will add acid, the mineral acid. Okay. It is totally transparent in color. So this is the test for sulphite, that is one anion sulphite. Okay. Next stage, we will show you the test for nitride. Now nitride, this is two different salt is there, one is nitrate and another one is nitrite. Now I will show you at first the nitride, NO2 minus, test for NO2 minus. This is also an weight test. So for this, one nitride sample will be taken. Nitrite salt is there. So in the same manner, we will again take a very little sample, add water to it to make the solution. Then what is the test? Now for nitride, for the weight test of nitride, it is ferrous sulphate test. So we will add acetic acid and then ferrous sulphate solution. So first to add acetic acid and then ferrous sulphate. Acetic acid and then ferrous sulphate. A black coloration will be there. Acetic acid and then ferrous sulphate. The color is depends as the sample. Yes, now it is quite black. Now what is the reactions involved here? For nitrite, yes, now it is totally black. Okay. So, this is the test for nitrite NO2 minus. Now, what is the reactions involved? So, first of all, a nitrite sample is taken and then acetic acid. So, in presence of acetic acid, it forms a nitrous acid, that is HNO2, which is easily decomposed. Suppose NaNO2 is taken. In presence of acetic acid, it will produce HNO2 plus CH3COONA, sodium acetate. Now, HNO2 readily decomposed to form HNO3 plus NO. This NO reacts with the ferrous sulphate, which is added at last to form a compound, that is FeSO4 NO, that is of dark brown color. FeSO4 dot NO, this is dark brown. Okay. So, this is the conformative test of nitride. Now, on the next test, we will see the test for nitrate. Now, nitrate is confirmed by the brown ring test. Now, for this, a brown ring will form at the junction of the two liquids NO3 minus. Okay. So, for NO3 minus, what is the reagent is concentrate sulfuric acid and the ferrous sulphate. So, just look at this. So, first step is the preparation of solution. So, sample plus water. tube some part, and then add ferrous sulphate and then concentrate H2SO4 by the wall of the test tube, and the brown ring will be formed. So look at this experiment now. Ferrous sulphate added. Now shake it to dissolve the ferrous sulphate. Shake it well. Now it becomes totally soluble. Now I will add concentrate H2SO4 here. So look at this. Now just look at this, the brown ring. Okay, the brown ring is formed at the junction of the liquid. So this is the conformative test for nitrate. That's all for today. We will meet again on the next class. So thank you everyone, and bye.